Hello and welcome to the New Space Vision podcast sponsored by LifeYo, where we discuss new space technology, finance and innovation with executives, founders and more exciting people from the startup and new space ecosystem. I'm Daniel Seidel.
And I'm Sam Shivara, and together we are the founders of the Earth observation company LifeYo and New Space Vision. Today's guest is Martin Jüssi, Space Mission Manager from the satellite analytics company KappaZeta. Welcome to the show, Martin.
Hello, thank you.
So before we dive deeper into the company and what KappaZeta is doing, we wanted to first get to know you a little bit better. So let's go back to the beginning. Before you decided to study geography and GIS and space-related things, were you space inclined at all? Was there any special moment where you decided, hey, I want to go in that direction?
It's an interesting question. To be honest, I never was a space nerd before the university at all. It all started with my fascination about the digital maps, and it really started with the GIS part. So in the bachelor's, I studied geography with the focus on GIS, and where that came from, it's an interesting story. It actually came from my kind of passion for computer games back then, and I was specifically keen on all those real-time strategy games. You may remember them from it's like Age of Empires and
Command and Conquer, Tiberian Sun, Red Alert. I played them all. Yeah, exactly. I know them. Yeah.
But especially the ones where you had map editors. I was always fascinated by the map editors and with the fact that you can basically build your own world in that game, and then you could play this game in the world that you've created. So when I learned in the secondary school that there is a professional domain like a GIS, geographical information systems, which is like modern digital cartography, where it's a profession of building maps and designing maps, then I decided that this is what I want to do. This is the way I want to go. And from there to Earth observation and the space, it was also a kind of a journey because by learning about the GIS and cartography, I eventually discovered, right, that remote sensing, like satellite remote sensing, is one way to produce data for this GIS. And you know how it is with young guys who go study, who want to become car mechanics or car engineers. They're obviously interested in cars. They like driving the cars, so they decide to go study engineering or whatever, mechanics. But it was the same for me. Like I was doing the GIS, and I got more interested in like, where does this tool come from? Like, where does this data come from? I was like a user of the satellites, and then I became more and more interested in the actual technology that produces this data, and that's the satellite Earth observation for you. And when I was in masters, I selected my master thesis in the Earth observation domain. I did flood mapping with radar satellites, and the actual cool thing is that the Kaupo Voormansing, who's the founder of KappaZeta, was my master thesis supervisor back in the University of Tartu, and it was kind of his influence or his suggestion to also go and study abroad, mainly for building your professional network and getting to see the world and know how other scientific organizations work, and that's the way I ended up in the International Space University. So it was Kaupo's suggestion to apply. I applied. I realized that this is a university that is specialized in the space domain, and I could learn more about the Earth observation technology, but at the same time get a broader look on the space domain. And I got accepted and spent a quite intensive year of an additional master in the International Space University. It wasn't like an exchange year. It was like a completely independent master study. But that is where I really kind of learned about the whole, like how big and how diverse the whole space sector or industry is. And that's where the kind of a fascination also came from.
Yeah, we actually have a high density of ISU graduates here at the New Space Vision podcast.
High.
Yeah, it's pretty high. It's shockingly high. I know it speaks for the program. What we also heard is for some it was also about the network, right? So can you confirm that you're still in touch with people from 10 years back at the time?
Yes, of course. Yeah, I can say that back then as a student, I couldn't appreciate the network that much. But now later in my professional life, I've learned to recognize how well these personal, these kind of personal experiences and personal connections may work for you and your business. So yeah, definitely, ISU is a lot about network, and there's a lot of people that come from ISU who are working in the space domain, and may have eventually be useful connections if you want to do something in the domain.
Yeah, and then also during the same time, you also went to Germany, to Oberpfaffenhofen, to the German Aerospace Center, DLR, right?
Yes. So that was part of my internship. So during the ISU studies, we had to do an internship, and I ended up doing the internship. Usually the ISU people, they would do the internships. The students would do their internships either in space companies, research organizations, or agencies. I mean, many people went to NASA, some went to ESA, but a lot of my course mates went to the industry, to work for various companies. I ended up in DLR mainly because I think that was the best match between my interests, which was like synthetic aperture radar technology.
Just a question. There was an echo.
Yeah, I have
starting.
Let me try to do that, and you continue, and then maybe you just ask the next couple of questions to not stop the flow here. Sorry, guys.
I don't know.
All good. So, and then after the internship at DLR, right, you actually took your first job, right, full-time job after actually graduating both, right, in Tartu and at the ISU. So, what brought you to CGI?
Well, I had two intentions. I did want to come back to Estonia, and I did want a job in the space sector. And CGI actually supported my studies a bit. They gave me a small scholarship, but not with a mandate that I would have to work for them afterwards. It was just basically their kind of contribution to the Estonian space education, supporting a student to go and study at the ISU. But back then, CGI was already kind of an established space player in the Estonian space sector, so to say, because they started even before Estonia joined ESA, and they were also part of the S-Cube-1 mission. I mean, they supported the mission, and they mentored some of the students there. But yeah, they were definitely one of the more advanced companies in the space domain in Estonia, and they seemed like a good match with my profile, because they had worked in space, mostly in the kind of a ground segment software domain, but they were interested in moving more to Earth observation, and I had a background like in Earth observation, and that was basically then my first full-time job with them was to kind of consult them in the EO domain. So basically teach the programmers. I mean, CGI is an IT company, right? They're really strong in programming, so it's basically to teach the programmers what Earth observation can do, and also what the users want to get out of the kind of products or services. It was kind of a now having this experience, I see it was kind of a like a business analyst for the EO domain. That was what I was doing back then as my first job.
Yeah. And maybe also for the listeners, that's also exactly the time where Sven and I met. And back then, for Earth observation, you could really feel the shift by 2016, 17, cloud technology, right? What is given for us today. Back then, it was not really applied in Earth observation. So you had all the cloud players going into the market, new technology. Also, AI was not where it was today, right? So people used basic algorithms like a random forest, and then convolutional neural networks came up. So you actually had a really exciting job in a fast moving field back then, right? And you also stayed there for 8 years.
Yeah, I was there for 8 years.
Yeah. But then basically, I wanted to ask you, did you also work on space systems then at CGI, or was it focusing on the software part?
It was all software for space systems, but also GIS. So I was on and off from space, but there was some involvement in the space domain, like always. Any software we did was either for space systems or GIS for the public sector. But the EO component was there, even if it was the GIS systems.
Yeah. And then while being at CGI in Estonia, there was also the European Space Conference happening in Tallinn, and this is where Daniel and I kick off LiveView. So that was I think in 2017. During the first couple of years you've been there, was also this event. I still remember, I think CGI was also a big sponsor, or was there with a lot of participants. But now we want to come a little bit back more to the future. And now, on LinkedIn you wrote that while studying at ISU in 2014 to 15, you always dreamt of building your own satellite mission. And now, 8 years later, you have the chance to do that in your hometown with an amazing team around you. And that's the reason why you joined KappaZeta as a mission manager for 3D SAR analytics. So how did that come? Did your old colleagues reach out, or how did you get back together? Maybe could you just quickly describe a little bit the Estonian space scene, like size? Is it a closely knitted network? And how did you get to KappaZeta?
Yeah, okay. Well, the Estonian space sector is quite small, so everybody knows one another. And even when I was working with CGI, we did collaborate with KappaZeta pretty much from the start. Like, we had joint projects and we kind of never stopped talking to each other. And this is not just between me and KappaZeta, it's between a lot of the companies in Estonia. Like, in the space sector, we meet up, we talk to each other quite often. This mission, I think the idea came from the actual needs. So a bit of background to the mission, and the company itself. I mean, KappaZeta was also founded in 2015, I think, by 4 founders, and originally as a kind of a value-added service provider. So it was a company with focus on EO analytics, mainly in the SAR domain, synthetic aperture radar domain, probably because of the cloud cover here in the Nordics. Like, you can't do much with just optical, but yeah, KappaZeta was a spin-off of the University of Tartu's Synthetic Aperture Radar Research Group, and KappaZeta was always focused on developing applications and developing, like, nowadays you call them EO services, right, based on existing data. But eventually they discovered that, you can only get as much from 2-dimensional data. So the kind of traditional planar optical and radar data only give you the kind of either the horizontal dimension or a kind of a spectral vision of what is happening on the ground. You don't have the kind of vertical dimension in the data, so therefore you can't really measure the height of anything you're trying to measure or detect. You can kind of, with the proxy methods, you can estimate the height, but the estimations based on just either some visual indexes or 2-dimensional radar data are never as accurate as from, for example, a traditional example is LiDAR. Like, you have the kind of vertical information in the data, therefore you can make some pretty good measurements or estimates on the actual tree height or the forest volume. And this kind of information, like, KappaZeta kind of saw that is lacking. And originally, I think there was a call for ideas for a kind of an Estonian national space mission from the Estonian Space Office. And there were some ideas put out from people. And it was then when, I think it was 2022 or 2021, when KappaZeta put out the idea that, let's make the Sentinel-1 data 3-dimensional. And the idea circulated in the small Estonian space sector, and companies were asked for, additional ideas or opinions. And I was with CGI back then, and I realized that we don't have a good new idea. So I just basically told them that I vote for KappaZeta's idea, that we support this.
Yeah.
But like, from that call for ideas, nothing ever happened. This was eventually dropped, but the idea itself seemed so good that KappaZeta decided to pursue it commercially. And it was kind of then when I also started thinking that, this is something really, really cool that I would like to do. When we eventually had this lunch with Kaupo, where he invited me to lead the mission, I felt like, okay, this is what I really want to do. And this is what I've always wanted to do, to develop a mission from the purpose.
Yeah.
So to develop a mission with a purpose. So if you ask me, like, why didn't I do this already, when I was studying, or like, why didn't I start my own company? I kind of lacked an idea. Like, I didn't have an idea of, what could really change the world. Because in my opinion, a mission always needs to, like a space mission always needs to have a purpose.
100%.
You can't launch a satellite just because for the sake of launching a satellite.
Many people do, though.
Yes, that is true. And this is also an experience like from this early stage, like you mentioned 2016, 2017, when all these EO services kind of started to emerge and all the platforms, cloud platforms. There was also buzz about like blockchain, etc., AI. I could see a lot of technology driven approaches or like applications. And the problem was always the uptake. It would always be, okay, the infrastructure is there, the missions are there, the data is there, but nobody's using it. And this is a problem that we, like in the future, like it's for all the humanity. I think in the future, we should avoid that. Like we should try
100%.
to avoid that. Like it's the value that has to come first. And then we need to realize that, okay, we don't have this data source that is really needed. So let's create it.
Yeah. Maybe because we already now all pretty deep into the into the company KappaZeta, could you explain? So you're building the SAR constellation. We will touch on what SAR is in a second, with the purpose of measuring 3D information. For what?
Mm-hmm.
Could you maybe just finalize, so to say, the company pitch?
Okay, so it's for providing a global overview of where our forests are and how they're really doing. So basically looking at forest height, forest volume, all the timber and carbon stock.
Amazing, because this opens up also a lot of follow-on questions which we've written down. Super exciting. Yeah.
Mm-hmm.
Yeah. So I mean, at Life, you're right. We also do a lot of 3D analytics. I mean, it's very interesting that you came from the analytics space, right? You identified the demand for more 3D information, and there are various methods, right, to do so. So you could, as you mentioned, use LiDAR, stereoscopic optical imagery, or radar. There are some other companies doing this, but so can you maybe explain a bit the approach you guys do? And yeah, because I think why you want to launch the hardware is clear, because it was not there, right? So can you maybe explain your approach?
Yes. So the idea is to fly passive SAR constellation, like a passive SAR receivers, information with an existing powerful signal source, such as the Sentinel-1. So the idea is that there already exists a very powerful SAR mission, the Sentinel-1, that is providing global coverage, very high revisit. So it's a 12-day revisit global coverage mission with a very long duty cycle for a SAR mission. So it's approximately 25 minutes per orbit. So if we want to produce three-dimensional SAR data, we would need multiple platforms. So one idea would be to launch 2 or 3 satellites flying information, also like producing the signal and receiving it from multiple angles. That would be much more expensive than using already powerful data source. So our idea is that we would like to enhance the existing data source, such as the Sentinel-1, with just passive satellites. So we fly 3 passive receivers in formation with Sentinel-1. And with that, with just a small extra investment and with passive receivers only, we could make the existing Sentinel-1 data much more valuable by adding this vertical dimension. And with the vertical dimension, you can basically measure the height and the volume of whatever you're measuring. It could be then forests, it could be buildings, it could be agricultural fields, the crops. We decided to focus on forests for several reasons. First of all, it's technically a bit more feasible than trying to measure everything, because the strength of the signal in the forests is much higher than, for example, on the agricultural fields. On the other hand, I mean, forest as a resource, like if you think of it generally, like forest as a resource, it's not just important only for forestry. I mean, it's important for a lot of market segments. So
and
that's go ahead.
And maybe for our listeners, because we talked about Sentinel-1, we talked about SAR, right? So Synthetic Aperture Radar, but now a small explanation for our listeners, that where your taxpayers' money is going to, right? valuable purposes. So the European Commission launched the Copernicus program. It's like the world leading Earth observation program, and they have the Sentinels, right? Sentinel-1, and the Sentinel-1s are actually radar satellites. The Sentinel-1C was recently launched, right? The others have been in orbit since 2014, I think 16, right? Something like this. But definitely 2014. One already had a failure, but now the new one is there. And radar works in a way that the satellite is putting out an active signal which reflects on Earth and comes back, right? And that's also where you with KappaZeta then actually connect to, right? So there's like the Sentinel-1C will send the signal and you then fly in a formation, right? Yeah. So we were asking ourselves, okay, so you're building a system, flying information with a satellite which does not belong to you. On the other side, it's a hot topic right now, like space traffic management, etc., collision avoidance. Aren't you making some people nervous with that approach? Or can you explain, like, or do you have such a big distance to these satellites?
Yeah, I mean, the straight answer is that, of course, some people get nervous when they hear about the idea. But the more we talk about this with ESA and the European Commission, the more we get validation that they like the idea. I mean, they like the idea of enhancing an existing constellation, or not even a constellation, like enhancing an existing satellite rather than like flying a new constellation. I mean, the idea is that we would be flying approximately 100 kilometers ahead of Sentinel-1, which is like from an orbital mechanics perspective is quite safe. But still, I mean, people ask those questions, and the answer to that is really that we need to think this through carefully, and we need to really take into account the orbital safety perspective.
Yeah. So that's roughly 12 seconds, right, ahead.
Yeah, but again, like the answer or like the approach is that we want to make ourselves as visible to both ESA and the European Commission to make sure that, you know, it doesn't come as a surprise to anyone that we're doing this. We have been talking to, I mean, we are already supported by ESA, and of course, like it is easier to get support, or like people feel safer when stuff is still on paper, right? But we've also been discussing with the European Commission, and I mean, they see our mission as a good potential for the Copernicus contributing missions program. Yeah. So yes, I mean, it's all about visibility and communication. Like if we were doing this in kind of isolation, then it would be much more difficult to get political support.
For me, when I heard about you guys, it was the first time I heard a company doing that approach, like taking a big public mission, and these satellites are really, really powerful machines, right, with a high cost. So are you the only ones with such an approach?
Commercially, as far as we know, yes. I mean, ESA themselves have another mission, like this new Earth Explorer called Harmony, that they plan to fly in constellation with Sentinel-1D. The technology is somewhat similar to what we are aiming to do, but I mean, Harmony has like ocean and atmospheric applications and no forestry planned at all. But again, the kind of approach there is that we exchange information with the Harmony team, and actually the principal investigator of Harmony is also involved in our mission. So it's again all about exchanging information and learning from each other. Yes, like scientifically, ESA are themselves doing a similar thing, but commercially, we don't know of anyone else currently like planning to fly a receive-only SAR mission like this.
Yeah, interesting. And I would also say that, so they don't only know about you, but it seems really like that you're collaborating. Interesting. Yeah. So obviously that's the space system. And there's obviously, as you've mentioned at the very beginning, you shouldn't have a space system without use cases and for no purpose, right? And what we, as a mainly analytics company, LiveView, believe is that obviously there's still a big gap between satellite data and what end users actually can then use. So are you planning to bridge that gap by yourselves? In other words, are you doing also analytics on top of the data sets you're producing? And are you planning to build applications as well in-house?
Yes. So this is actually KappaZeta's current core business. I mean, currently we are building analytics and applications without having a proprietary data source. So we're just using the data sources that are available. So we intend to do that also in the future. This doesn't mean that we will keep this data only to ourselves. So, you know, one idea would be also to sell the data itself commercially, but we will definitely build on our existing commercial relationships with our current customers and also on the expertise we already have in developing SA applications, because not everyone can build SA applications, particularly in the bistatic or multistatic domain.
Yeah, and that's a great bridge to the next subject, which is you've mentioned that you already have standing relationships with existing customers, and you've mentioned forestry before. So are these customers in the forestry space? And if so, could you explain us what a typical customer of yours looks like?
We started from the agricultural domain. We also have a customer now in the public forestry domain. But so far, KappaZeta's business has mainly been business to government. So our first customers are actually, first customer was the Estonian Agricultural Registries and Information Board, who act as the kind of agricultural paying agency in Estonia. In Europe, we have this common agricultural policy where like every country needs to implement that policy in their country and basically pay subsidies to farmers, and they need to also check if the farmers really comply with the requirements of the subsidies. So we offer that kind of Earth observation based compliance check service to the Estonian government and also to the Danish government. So we're serving two governments there. We also work with the Estonian Environmental Agency, who are also more interested in the forestry and general environment monitoring. And there's also some defense involved. Regarding business to business, so far, the core business in the B2B domain has been actually selling analysis-ready SA data, because this is something that a lot of the commercial companies who build analytics to their own end customers, they don't want to do. Like they don't want to worry about, the co-registration of the SA images or, getting the kind of analysis ready information out of that. So they left that to us and purchased the kind of end, like let's say SAR end product from us to use it in their own analytics. In the world of like commercial forestry, also like commercial, like voluntary carbon markets, it's now all about these kind of pre-arrangement and, letters of intent and these early user requirements discovery. We haven't yet achieved, we haven't yet signed any contracts in the kind of private forestry domain.
Yeah, but I think on your website you also write, and you touched on this briefly, the dual use / defense use case, right? And there you also mentioned that the defense applications in the defense space were connected to forestry. Could you maybe just touch on how such a use case might look like?
Yeah, if you think about the multistatic SA, so synthetic aperture radar, from where the signal is measured from different angles, which is what the 3D SA mission can eventually provide. This is where you can actually start looking into the kind of vertical distribution of the forest canopy as well. And you can draw conclusions on the forest trafficability and the also ability of the forest to cover infrastructure, which is something that, many of the militaries do not have on a large scale by default. And this is very good for maneuver planning, defense planning, but also for like semi-civil applications like evacuations planning. And this is where the kind of multistatic SA can help.
Maybe then just like doubling down on this, and just for me, a clarification question. So with your technology, you're not only able to identify the canopy height, but also the density of different layers from surface to canopy. Is this correct?
Yeah.
That's interesting. And what kind of granularity, or resolution vertically?
The vertical resolution, hard to say now.
What's the ambition? What's the goal?
I mean, the horizontal resolution will be limited to what the Sentinel-1 can offer, and later when we have the next generation satellites like Roselle or Sentinel-1 next generations, we can come down in resolution. So the Sentinel-1, the current Sentinel-1 offers 20 meters resolution, which is still not that interesting. Yes, horizontally, which is not that interesting for military purposes. But the next generation Sentinel-1 will be down to 5 meters, which is already much more interesting. In terms of like vertical resolution, in theory, like signal itself. The signal itself is, the SAW wavelength is C-band is like 5.4 centimeters, and if you measure the phase, you can divide that by 360. So it's really like on a millimeter level, but this doesn't mean that you get like a millimeter.
Yeah. So moving a bit forward, because for all the investors listening, we can say there is demand for this type of data and there's a gap in the market. But basically, we can't wait. So what's the timeline?
Our current ambition is to launch the mission at the end of 28. And we are kind of, let's say, constrained also by the timeline because the Sentinel-1C is already up there. There is also the Sentinel-1D coming up, right? Which is to be launched later this year. But there's also the Harmony mission planned to be in orbit with the, information with Sentinel-1D. So our current plan is to stick to Sentinel-1C, and the more we delay, the older the Sentinel-1C will be.
Yeah.
But yeah,
so
it's late 28 is our current ambition.
Yeah, so it's a really exciting mission, specific profile from a launch perspective. What we hear on the market right now is SpaceX. You need to book in the coming months to launch in 28, so that's a constraint. But do you plan to launch with SpaceX, or are you looking for another micro launcher? You need a dedicated orbit, right? So
we need to be in a very specific orbit. Yeah. So we are most probably looking at a dedicated launch. So we are really, really hoping to see these European new space launchers doing well in the next months and years.
And I think that would be another topic for another podcast. Just looking at the time, there's one question before we go to the wider ecosystem, which I wanted to ask you, because we see, there are different type of companies like hardware manufacturers who have designers who design hardware, manufacture hardware, etc. And then there are software companies. You were a software company, and now you build a very complex space system, a radar satellite. So I've seen your team has grown 80% in the past 2 years, according to LinkedIn data. But it's still a small team, right, with 25 people. And how do you build everything and design everything in-house, or do you still focus on the software and have contractors who actually design and manufacture the hardware part?
So our focus would be to keep ourselves as a kind of a mission prime, so focusing on systems engineering, also on the software products, and maybe some design of the payload and the payload software, but many of the hardware bits we plan to outsource to specialist partner companies, because most of the capabilities that we need already exist in other companies. So we don't have to build much hardware ourselves at all. And this is also the way to make it happen this fast, because if we would have to start really building from scratch, it would take us much more time.
Yeah, I once said it's easier now to actually launch satellites than building the software to analyze the vast amounts of data.
Yeah. At scale, for sure. And I think that's also really shows where the ecosystem has come to, because right now really you have like a rich ecosystem of players which can build different subcomponents or have already done that, and you can really assemble that, and that's also where the innovation starts. And now you have that layering of innovation happening at all different levels of the stack, from the component level to the systems level to the software level. And it's extremely exciting. I'm sure we could talk for ages, and anyone who was previously a little confused about hearing millimeters when talking about space data, well, just Google ZAR and read the Wikipedia article. You will likely be more confused afterwards, because it takes you quite some time to understand all the details and complexities of dealing with radar data, but that makes what KappaZeta is doing even more interesting. Maybe talking a little bit about the ecosystem and the competitive setting you are in, right? Because there are also other companies which want to offer 3D data from space. There's Array Labs on the one hand side, there's NewView on the other side. And some of them have other technologies in place and want to use them. So how do you see that competitive playing field mapped out? Where do you have advantages over them, and how do you think also that you're not even competitors potentially?
Yes, I mean, talking about the companies you mentioned, I mean, obviously they're trying to do similar things. They're trying to do it with dedicated illuminators. In case of Array Labs, it's their own constellation also producing the signal. That is going to be much more expensive to get global coverage. So that's for very specific use cases, for very high resolution, like focused areas. That is definitely much better than we can provide. But for like getting a constant global coverage with high revisit, I mean, that is what this kind of receive only flying with an existing powerful illuminator is really good for. So let's say the use cases differ a little bit. Technology and the intention of the technology is really similar, but yeah, in terms of and also talking about NewView, it's LiDAR is an excellent technology, but the unit cost of producing that data is going to be much higher. So for actually getting global coverage, it's going to be way more expensive. So there we see that we can have a cost advantage, particularly when it comes to applications that need dense time series, so kind of high revisit. That's where we can come in without building a massive constellation of hundreds of satellites. But also, I mean, of course, the competitive landscape is such that, you know, there are existing constellations up there, like from ICEYE, from Umbra, from Capella. I mean, it's only a step for them to kind of put their 2 satellites working in a bistatic configuration and also getting that kind of information. But I mean, for them, it's also, you know, it's about very focused, high resolution images of small areas, which they're really good at. And it's not really the kind of applications that we'd be aiming for.
Yeah. And I think oftentimes it's obviously that also scanning, and then you oftentimes have different mission profiles, obviously for figuring out something at large scale, and then another mission which goes really deep into the detail, right? And it's also, I think, where the combinations of different companies or different data providers really is super valuable for analytics, right? And I mean, as you've mentioned, right, since you also want to own the end user application, nothing holds you back from potentially buying data from any of the other providers, which at some use cases in some areas may provide higher resolution data. So interesting. You've mentioned ICEYE, right? And obviously ICEYE being based out of Finland, about ferry ride from the Estonian seaside away. Do you have people from ICEYE working at KappaZeta's?
Not yet.
Not yet. Or maybe in the future as you grow, because obviously they having now hundreds of employees with so much radar experience and expertise, right? That is then potentially a natural fit for some of them to come over.
Yeah. This is the like the Silicon Valley effect, right? Which I somehow see, like how an ecosystem is evolving, right? And that you then at some point in time, when you have these first successful companies like ICEYE who scale, also Planet, we have a lot of Planeteers working at LiveView now, right? So it's really evolving, really exciting stuff, and fast ramp up time, etc. But we touched on it in the beginning, like the Estonian space ecosystem, right? We talked about S-Cube, right? Our third podcast actually was with S-Cube, where you know there's also a strong connection. One thing I wanted to ask you about the Estonian space ecosystem, like that's our perception, why do we hear more about Estonia from the Baltic countries than Lithuania or Latvia? Like, do you think they have a specific strategy, or is it just the tech ecosystem there is different for space? Or is it really the S-Cube and you know, this environment?
Yeah, I can maybe think of two reasons. So first, Estonia is quite well known for IT and deep tech and a number of startups in general. And it all started with Skype in 2003, from which like later a number of other unicorns emerged. So there was Bolt, there was Pipedrive, there was Wise, and that has kind of evolved. And that's now also the reason why I think we are number 1 in Europe for venture capital investments per capita. And this is probably why you're hearing about these companies a bit more. The second reason could be that the Estonian space industry, the kind of commercial industry, has evolved quite a bit after the launch of S-Cube, and also after Estonia joined ESA in 2015. So the launch of S-Cube was in 2013, and we joined ESA in 2015. So some of these S-Cube engineers founded their spin-off companies, some of which are doing quite well. Latvia and Lithuania also have a very strong space sector. For some unknown reason, they're just not that visible. I mean, Latvia has a long heritage in like academia in space, and I mean Lithuania has, for example, nanoavionics, which is a good example of like a prime example of a successful new space company. But I think it's just a kind of communication of Estonia as an e-government and e-country with a lot of IT expertise that is also kind of having this collateral information flow into the space domain.
But I really see a pattern, you know, S-Cube for the listeners, right? It's a program by the University of Tartu, right? Like for students to really launch a satellite, launch a satellite, operate a satellite. And we have seen, for example, ESA Aerospace also with a VAR group in Munich, right? Like a student group which developed a rocket and also Hyperloop now and so on.
Mhm.
And in Berlin, actually, right, the Technical University of Berlin has launched more than 30 satellites. And that's why in Berlin, actually, there are also a lot of small set companies. So these programs where people really do practical work, have such a huge impact on the ecosystem, because you can learn a lot in university, but at the end, doing the stuff makes you launching a company, right?
And you will remember it much better than just reading the textbook and then forgetting it after the lecture again.
Yeah. But it also people meet there, right? People who really outside of the standard lectures who want to build stuff, do stuff, they meet at these locations.
Amazing. Well, we're coming to an end of this episode, but Martin, we want to ask you, like we ask every other guest, who should we bring on next time to the podcast?
Yeah, I think we now touched the Estonian space ecosystem briefly, and I think what Estonia is now very strong at is space cybersecurity. And there's another, I'm saying another because KappaZeta is also in a way a spin-off of StCube in a way, but there's another spin-off of StCube called SpaceIt, and I think its founder Silver Lodi would be a very good person to talk on this podcast. He's a nice and charismatic guy, so you'll enjoy it.
Great. We will definitely make sure to reach out to him, because space cybersecurity is something which we haven't had touched yet. And so therefore, I think definitely a subject which we should look at as this topic becomes more and more important to everyone who is active in the wider space ecosystem. So thank you very much, Martin. It has been a great pleasure for us to talk today about you, about your history, KappaZeta, and what you're up to. Extremely exciting, extremely interesting for us, for our application, but I think so many more applications out there. So for all the listeners, thanks for tuning in. Make sure to follow Martin and KappaZeta on all the socials. Make sure to tune in next time when we have the next New Space Visionary here on the podcast, and follow us on our socials. So thanks again, Martin. It was really interesting.
Having me.